Hi, in this lecture we will talk about forward diffusion. Let's say that we have clear image x0 at time step 0, and here we will add Gaussian noise to this image and we will get this Gaussian distribution. The mean of this Gaussian distribution will be equal to x0 times the square root of 1 minus the variance. And the variance here, it is the variance of the noise, of the Gaussian noise that we added to x0. And we will use this distribution to get the value of x1 variable at time step 1. And we can represent this distribution by q of x1 given x0. Now let's say that we took the value of x1 variable from this distribution. Now we will add Gaussian noise to this value and we will get this distribution here. The mean of this distribution will be equal to x1 times 1 minus the variance of the noise that we added to x1. We will use this distribution to get the value of x2 variable at time step 2. We will represent this distribution by q of x2 given x1. And we will do the same thing again and again until time step t capital. So in general, q of xt given xt minus 1, it is equal to this Gaussian distribution that we will use to get the value of xt variable, where the mean of this distribution is xt minus 1 times the square root of 1 minus the variance at time step t. And here is the variance of this Gaussian distribution. This simple here, it is just another way to represent any Gaussian distribution. And there are many other ways. Here in this way, we just need to put the name of the variable and the mean and the variance of this Gaussian distribution. So now this distribution q of x1 given x0, it is equal to the Gaussian distribution that we will use to get the value of x1 variable, where the mean of this distribution will be equal to the square root of 1 minus the variance at time step 1 times x0. And here we will put the variance of this Gaussian distribution, which is the variance at time step 1. The value of the variance will specify the amount of the noise that we will add to x0. And this I capital here tell us that we will apply the same variance for each pixel in our image. As you know, each variable here represents an image. We talked about this previously in Gaussian distribution lecture. Here is the most important thing. Let's say that we want to find the distribution of all possible sequences of x1 and x2 variables given x0. We call this distribution joint distribution, and this distribution will describe multiple variables. Here in this case, two variables, x1 and x2. This distribution will have the probability density for each possible combination of x1 and x2 variables, or in other words, all possible sequences of x1 and x2. It is equal to the distribution of x1 variable given x0, which is q of x1 given x0, times the distribution of x2 variable given x1. So q of x2 given x1. This is forward diffusion. So now forward diffusion, it means finding the joint distribution for all the variables from x1 to xt capital given x0. Or in other words, in forward diffusion, we are trying to find the distribution that will give us all possible sequences from x1 to xt capital given x0. And we can use this pi symbol to represent this multiplication process. So here we will write pi from time step 1 to 2 of q of xt given xt minus 1, which is equal to this multiplication here. In general, if we want to find the joint distribution of x1 to xt capital, we just need to multiply all the intermediate conditional distributions of each xt given xt minus 1. Let's say that we want the joint distribution for all the variables from x1 to x10 given x0. Or in other words, the joint distribution for all variables in the first 10 time steps given x0. So here we need to multiply 10 distributions together to get this distribution, which is something difficult. So we need to find another way to solve this problem, to move us directly from x0 to any time step and avoid using this joint distribution. Actually, what we really need is to find the value of xt directly, in this case x10. Here we can extract x10 from this joint distribution, but this thing will be difficult. Actually, it is computationally expensive, and we need to do integration to remove all the other variables from x1 to xt minus 1. Here in this case, we need to apply 9 integrals to remove the variables from x1 to x9. By doing this, we will be able to find the distribution that we will use to get the value of x10 variable given x0. So in other words, when we increase the number of time steps, things will become more difficult. In the next lecture, we will talk about reparameterization trick that we will use to solve this problem and finding q of x10 given x0 directly.